So, what we're going to talk about today is we're going to start talking about waves, okay? And how we can use, we're going to talk about waves and how they're related to energy, okay? And we're going to look at that and we're going to try to figure out how we could use waves to maybe create an alternate energy. So our learning goals for this unit, or this task rather, is we're going to explore how waves have certain characteristics. We're going to learn about the characteristics of waves. Guys, pay attention up here. Thank you. So we're going to learn about the different characteristics of waves and how their characteristics relate to their energy. Okay? So we're going to explore water waves first. That's what the bins are on your table. We're going to play around with those in just a minute. Well, just a few minutes. And so we're going to identify characteristics of those waves, and we're going to kind of formulate a definition. Okay? And then we probably won't get to this today, but we're going to use a computer simulation to kind of play with, the different characteristics of waves and see. Okay, so the amplitude of waves. So this word amplitude, when we measure the amplitude of waves,
isn't it how big the wave is?
It's how big the wave is. It's a measurement of how big the wave is. And so right here in this picture, we have this black line would be, if there was no energy in the wave, we would have this flat line right here. Okay? But there's, something happens, a rock falls into the water, or, wind pushes water and creates, puts energy into the system, and it creates a wave. And so the amplitude is measured by, where the wave would be at rest to where it is to the peak or at the bottom of the trough. So this is called the peak of the wave, is the high point of the wave, and the trough is the low point of the wave. Okay, and the amplitude is a measurement from, the origin, or where it would be with no energy, to where it is at the peak, or vice versa at the trough. Okay, so that's amplitude. Any question about amplitude? Here we have an example. Okay, so wavelength is the measurement of the wave. Okay, so it's the measurement from, either the bottom of the trough to the next trough, or the top of the peak to the next peak. Okay, those are wavelengths. Okay, and just you can have different sizes of wavelengths. Okay, that give your wave different characteristics. Okay, frequency is the amount of waves in a space of time. So if we have here, we have low frequency, where we have maybe, what is this, maybe 1.5 waves there. Okay, whereas here we have high frequency, the black line would represent our time. And so here we have, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 waves in the same amount of time. So frequency is how many waves per time. Okay? About that in a little bit. Okay, how does matter and molecules, how do they factor into when we're talking about waves? What is matter and molecules, and why are they important when we're talking about waves? What do you guys think? Lawrence, go ahead.
Well, if there's a higher frequency, doesn't the molecule move faster?
Okay, if we have a higher frequency, the molecules move faster. Good. Good. We can build on that. That's a good thing. What else? What do you guys think? How else does matter and molecules affect waves? Go ahead. Maybe molecules make up the waves. So very good. Waves have to travel through something, right? Unless they're so light waves kind of are a little bit different. They can move in a vacuum. But other waves, like water waves, have to travel through water. And so there's water molecules that the wave travels through. Okay, good. Mike?
So say right now if I'm talking, if I talk really loud, the room below us could hear us. So if, sound waves travel through air, and if they're, I guess high frequency could travel through, or
Certain frequencies can travel through
yeah.
certain substances, okay? Depends on how dense those substances are.
Yeah.
But yeah, so you were talking about sound waves. Sound waves travel through the particles or the molecules of the different matter in the air. Okay? Did I say what you were going to say, Ryan?
Dang it.
I'm sorry. Go ahead,
Well,
Zach.
Sound waves, like, do they move through the molecules or do they just move around the molecules?
So, do they move through the molecules or do they move?
Like, not move around, but like move the molecules back and forth. So, like, kind of a chain reaction of the molecules, like one
Yeah, so you're right. They do create, the way waves work is they kind of, they make what you were saying is like a chain reaction.
bump each other around.
They bump each other around. We'll get into more of that in the lesson, but that's a good observation. Good. Kira. Okay, so we're gonna use the bins that are on your table to demonstrate this. I want you guys to kind of play with waves. Try to, hold on, before you do that, now, this is not like, I do not want people to get wet, you know, splashing people with water. I want the water to stay in the bin. There should be no water on your table. So when you drop these things to make waves,
The bottom of our bucket's wet, so if we move the bucket, there's water.
that's all right. Yeah. Okay, so just be careful when doing this. So you wanna kind of play with these things and try to observe like amplitude, wavelength, and frequency. See if you can do different things to kind of get different results here. Okay? So I want you to make those observations. Again, I don't want you to get wet. One experiment that I do want you to do is listen close here. So I want you to take the styrofoam ball and put it kind of like, you know, off center in the bucket, and then I want you to drop the marble, see how it affects the styrofoam ball, and then drop the tennis ball and see how it affects the styrofoam ball. Okay, so start off with that experiment. So what I want you to do is kind of play around with these things, and then I want you to come up and send, you know, one person up from your group to kind of write maybe, you know, 2 or 3 things down about the characteristics of the waves that you observe.
Why did I choose
So what did you learn from this activity? Come up and write. Less surface area creates weaker waves with more amplitude, high frequency. Less surface area. Somebody explain that one for me. Less. What is the surface area? Go ahead.
So, like when I drop the marble in the water, that has less surface area when it impacts the water.
Oh, okay, so the surface area of the object that you drop. Okay, so not only does weight have an effect, or the mass of objects, but also how large they are, how much water they displace by their size.
Or if it's not something being dropped in, like the area where the force is dispersed.
Okay, so if you're just moving the objects around, the larger objects, the objects with the larger surface area, you know, create larger waves. Interesting. I was thinking, when I saw surface area, I thought like the surface area of the water. You're talking about the surface area of the objects. Very good. Okay, the waves / ripples are generated from the origin of the impact in every direction. Mass, surface area, and force have an important effect on the size of the wave / ripple. Very good. Kind of is all encompassing. Good. Okay, and then this was a really good definition of a wave, I thought. So wave involves the transportation of energy without the transportation of matter. In other words, a wave can be described as a vibration or disturbance that transports energy from one location to another. A straightly curly lock of hair. I'm not sure what this curly hair has to do. Explain the curly hair thing.
It was a joke.
It was a joke. Oh,
Because wave, like curly, you know, like wavy hair.
oh, wavy hair. That's a lot of the guys didn't get the joke. I didn't get the joke. It's a hair dryer, guys. Wait. I didn't get that. Okay, that's good. So I like the first part. So what we observed, so in that experiment that I asked you to do, where you put the styrofoam ball in and then drop, create waves around it. If you notice, the styrofoam ball just didn't get pushed by one of the waves and get pushed all the way to the outside of the container. It bobbed up and down, and the reason why it bobbed up and down is because the wave, is transferring energy to the different molecules, and so it's not actually, the molecules aren't actually traveling to the edge of the basin. So let's draw this for a visual representation. Get a thing that works. So if we have our basin here, and we have, let's see, we have a wave like that, okay? And let's say we dropped, let's say our styrofoam ball is here, and just for funsies, we dropped the marble right here, okay? And so we created this wave here, and so what happens is we have energy. We're just going to do a star here to represent energy, and we have molecules, and I'm just doing the surface water molecules here, but really we have molecules throughout the entire thing, right? And so just like you're saying here, it creates a chain reaction of energy. And so we drop it, and it passes the energy on to the molecules next to it. And so when it gets to the styrofoam ball, it lifts, that styrofoam ball just moves because it's on top of, these molecules right here. And as they go up and down, they move the ball up and down, but they don't move it, they don't move it this way. It just moves, up and down. Okay, not that way. Okay? Does that make sense why that happens? So